Okay, this next presentation is on identifying lamprey. So, I am not saying identify every lamprey in the project. That is not what I am recommending. I do not want you all to do that. But I do want to empower you so that you can identify lamprey if you're interested. So the hard thing with lamprey is that we actually do have to look kind of closely at them to identify them as species. But that is really valuable data. So depending especially on the monitoring of projects, if it's a passage project, are there lamprey above that passage barrier before the project, or are they there after? And what species are there? That could be some really valuable data. It also is just really important because, as I mentioned, distribution information is kind of one of the main tools we use to understand these populations, because we don't have good trend and abundance data in many places. And so identifying the species can also help us know where different lamprey species are on the landscape. So this is, if you are interested, if you want to identify the species, these are the key characteristics that we're looking at. But I, again, want to reiterate, I am not expecting you to spend a ton of time at a stressful situation identifying lamprey species. But it is really cool once you know, because you can look at them relatively quickly and see what species you got. So, as I mentioned just now, we do have this need for better identification, because then we can inform what we know about these lamprey across the landscape. And that is also at the life stage. We don't have a lot, oftentimes when we get data about lamprey, it just says it's lamprey. It doesn't tell us if it's an adult, it doesn't tell us if it's a larvae, it doesn't tell us if it's juvenile. And so having a little bit more information can be really valuable to understanding when lamprey are using these environments, when they're moving, and what species are present. We recommend conducting species level larval ID at around 65 millimeters, even 70 millimeters, because the smaller larvae have indeterminate characteristics. So if you've got a lot of small larvae at a site, don't worry about it. We have plenty of people, I'm myself included, who have looked at a ton of larval lamprey, and I oftentimes, for those smaller ones, just don't worry about it. So larval lamprey is what we're probably going to see in the field most often, so I'm going to be focusing on that, but then we'll talk about the other life stages as well. So brief reminder, we've got 2 species of native lamprey here in Washington. Our Pacific lamprey, they're in the Entisphenus genus. They are our largest lamprey. They are anadromous. And so in some cases, the size of the lamprey can be used to determine if it's a Pacific lamprey. Basically, if it's, if it's above around 370 millimeters or around 14 inches, that is going to be a Pacific lamprey, so our largest lamprey. In the Puget Sound and Washington coast, we have some tricky cross-size adult lamprey. So we actually get a dwarf Pacific lamprey in this region. They can be quite a bit smaller. And so they will overlap in size with our Western river lamprey adults. So you have to look pretty closely at them to determine which species it is. Our Western river and Western brook lamprey are in the Lampetra genus for now. The genus will be changing, but for now it is Lampetra. And so they are, again, the same species, but have different life history strategies. And so our Western river lamprey are also anadromous. They're going to get larger than our Western brook lamprey. So the size of the adults can also be used to distinguish the life histories. But at the larval stage, we cannot tell these 2 life histories apart. They are going to look exactly the same. So we oftentimes will break out our larvae into the Entisphenus group and the Lampetra group, or Pacific lamprey and Lampetra. For the life cycle quick review as well, the larval lamprey stage is the freshwater stage, where they are filter feeders for up to 10 years, potentially longer. But that stage is what we are most commonly going to come across at our sites. The juvenile stage is equivalent to our smolts. They're going to be transforming and getting ready to go out to the ocean. They will have visible eyes, a very distinct mouth with teeth developing, and they're going to start to be silvery in color. So the color is going to be a key characteristic for us to identify the juveniles. And then the adults, we will use the dentition and the size. The juveniles, we will also use the dentition to look at what species it is. And so we're actually going to be looking at the teeth patterns. So this is just a quick review. Larvae, no visible eye, brown in color. Juveniles, visible eye, silver in color, we're using dentition. And adults are going to be our largest lamprey. We're using dentition and size. So for larval lamprey, these are some pictures. We've got our Lampetra species on the top, and then our Pacific lampreys on the bottom. And a lot of times people will send photos of larval lamprey and they will focus on their mouth, their oral hood, or their gills. It'll be a picture of their head. That is actually totally useless. I cannot tell what species it is based on that part of the larval lamprey. So we are actually going to be looking at the tail, and that is where we have distinguishing characteristics that will tell us which species it is. So that is not intuitive. So when we're talking about tail, we've got two characteristics that we're going to be looking at. So the caudal ridge is the center part of the tail. It is kind of the structure of the tail. And then we have the caudal fin, which is the thin membrane around the caudal ridge on both sides. And so the characteristics of both of those elements combined allow us to identify two species. So for Pacific lamprey, the elements that we are looking at, for the caudal ridge, it's going to fade in color towards the tip of the tail. So the more central part of the caudal ridge is going to be darker, and then we will have this kind of triangle at the end that's going to be lighter in color. So it's fading at the tip of the tail. For the caudal fin, the fin is going to have pigment. So it's going to have color, and it's going to be darkest kind of along the caudal ridge, and then it's going to fade out towards the edge of the caudal fin. But most distinctly, it will have color. For Western brook and Western river lamprey, so again, our Lampetra genus, it's pretty much the opposite. So the caudal ridge itself is going to be really dark and uniform. In some cases, we actually saw a specimen the other day where the whole body was kind of a brown, a lighter color, but it was still very uniform. So the color at the tip was the same as the color closer to the center of the body. There was not a difference. So it won't always be really dark like this particular individual, but it will be uniform. The caudal fin will sometimes have some speckling, some like peppering right close to the caudal ridge, but oftentimes is clear or opaque in color. There's not a lot of pigmentation in the fin. So they're kind of opposite. So here are some examples of tail photos for Pacific lamprey. And the key characteristics are that lighter at the tip. You can see they kind of fade in color in all of these cases. It's helpful to have a white background or a light background to look at this, because sometimes it can be a little bit small. Like this is a smaller individual, so that clear kind of window at the end is a little harder to see. But we have this fade in color, and then the caudal fin themselves has pigmentation. It's usually darkest right along the ridge and then fades out towards the edge of the fin. So those are Pacific lamprey. And then these are examples of our Lampetra fish. So really dark and uniform for the caudal ridge. Again, doesn't have to be as like dark, almost black color, but just uniform. And then oftentimes what we'll see these clear fins that are just, there's very little pigmentation, if no pigmentation. Sometimes, again, it will have that peppering really close to the ridge, but very minimal pigmentation overall. One of the other characteristics that can be kind of a secondary characteristic that's really evident in this specimen here is that oftentimes the fin will wrap around the edge of the caudal ridge. And that really is much more common in our Western river lamprey, Western brook lamprey, our Lampetra. So you can see this clear membrane that wraps around the tip. That is kind of a secondary characteristic. It's not necessarily one that I always go to, but it is sometimes useful to look at that. So that's the larvae. The adults and juveniles, we actually use the patterns of the teeth to identify species. So the most useful teeth in this are the endolaterals, or the lateral teeth, so those teeth on the side of the mouth. We also use the superorals, the top teeth. Those are particularly useful in the adult stage, but can be a little deceptive in the juvenile stage. That's why we stick with the endolaterals. And then you can also use the infraorals. These are kind of not as commonly used, but occasionally I'll get a picture where I can't actually see these other ones, and I can look at the infraorals. And so that's a kind of backup. So for juveniles, as I mentioned, the endolaterals, the lateral teeth, are the most useful, and we're actually looking at the rows of teeth. So for Pacific lamprey, there's 4 rows on the side, those side teeth. For our Lampetra species, there are only 3. So this is going to be a really easy characteristic to look at, count. It's usually pretty clear, the rows. And again, 4 Pacific lamprey, and then 3 for our Lampetra. The superorals, those top teeth, for the Lampetra, there's always just 2 of them, and those can be really distinct and easy to see, especially as they mature. The tricky thing with Pacific lamprey is that they have 3, but sometimes this middle cusp is really hard to see. So at the juvenile stage, that's again why the endolaterals are just the easiest, most defined characteristic. As they get older, this will get really defined because their scientific name is Entiphenus tridentatus, and that tridentatus means 3-toothed. And so this is actually a very important aspect of their dentition. The infraorals, again, they are not, I don't use them very often unless I really can't see any other teeth, but there's less. There's 5 to 6 of them for the Pacific lamprey, and there's more, there's 7 to 10 for the Lampetra. So here is a picture for that tridentatus. This is Pacific lamprey, and they've got this really distinct 3-teeth pattern. So at the adult stage, that is usually a really good indication and easy to see, but they also will always have those 4 lateral teeth that can be used for identification. And in this area, this can be really important because, again, we have the dwarf Pacific lamprey that seem to be pretty common in the Puget Sound, southern BC, and Washington coast. And so they will overlap with the adult size of Western river lamprey. And so you have to actually look at the teeth to see which species you have. For Western river lamprey and Western brook lamprey, they start to be a little bit more distinguishable for life history at the juvenile and especially the adult stage. So this middle one is kind of an intermediate transforming Lampetra. You can see that it's got 3 endolateral teeth, 2 superoral teeth. It's kind of lighter in color. If you saw the whole body, it's a fairly light kind of gray color. But as they mature into Western river lamprey, they will get really silvery. So again, these are the small equivalent. They're going out to the ocean. They want to have that nice silver color to hide in the marine environment. So they're going to get really silvery. We'll have some pictures of that. They will also get really more defined teeth. So you can really see that the teeth popping out in this mouth. This is a juvenile Western river lamprey, and it's getting ready to feed parasitically. Versus the Western brook lamprey, they don't really need their teeth for anything. They're not feeding, besides filter feeding in the larval stage. They just need that oral disc to move rocks to build their red and then suction onto each other to spawn. So they end up getting these just like really just not well developed teeth. So oftentimes for our adult Western brook lamprey, their mouths will look like this, and our Western river lamprey will just have way more defined teeth. They'll be nice and sharp. And they're more used for feeding rather than just a kind of relic teeth. So these are some pictures of juvenile Pacific lamprey. oftentimes, especially in the early stages, this is a relatively early stage of transformation. Again, this takes months and months for them to make their complete transformation. They start to grow their eyes, they grow that oral disc. Their esophagus actually detaches during this time, and their whole like way of being is reoriented, because not only are they going to the ocean, but they're going to feed parasitically. So they went from being a filter feeder with no teeth, no eyes, to being a parasitic lamprey that's going to be in the ocean. So huge transformation. So in the early stages, you can also use their tail features to identify them. So you'll have just a lot more pigment on the tail itself, but it starts to become a little bit harder as they get to be closer to going out to the ocean. Typically, we see much more pigmentation for the Pacific lampreys than the Western River lampreys, but we'll also end up seeing coloration on some of the Western River lampreys. So the dentition is really the tool we use to identify them. And so again, we're looking at the 4 lateral teeth. This is a good example of how it's only got 2 supraoral teeth at this point, and so it has not developed that 3rd cusp. And so having those 4 teeth on the edge is going to be our best example. And they will suction on to anything. They're like comfort zone is just holding on to something. So if you put a rock in front of them, they're going to suction on that. If you put a mason jar, put them in a mason jar, they'll suction onto that. Put them in a fish viewer, they'll suction onto that. So it's a really convenient way to see them. We've actually also used reading glasses where we just have stuck them on there, and they'll suction on that, and then you can see their dentition pattern. So takes a little bit more to look at them. But the dentition is the kind of most reliable way to identify. Adult Pacific lamprey can kind of vary in color, and that is related to how recently they've migrated from the ocean versus how long they've stayed in the freshwater. So they'll start off with quite silvery coloration, a little bit more gray, and then they'll usually get into a darker brown, or even sometimes they'll look really dark like black. So again, at this stage, because we have overlap in Western River lamprey and Pacific lamprey size, we will use the dentition at this life stage to be able to identify them as species. So this is where that supraoral teeth can be really easy to identify them, because they're just going to have that really prominent 3 teeth. For Western Brook lampreys, this is again our resident adults. They tend to be pretty brown in color. So they will have developed eyes, which generally are smaller than our anatomous lampreys. They're going to be kind of brown in color. Again, they'll have this one has some relatively defined teeth, but they're usually not as defined as the Western River lamprey. They're kind of dull. They're just not as sharp. They're not ready for feeding. And so and they're also the smallest of the adult lamprey. So they're only around 100, 180 millimeters, 4 to 7 inches. So when you see small lamprey spawning, it's very likely that those are residents. They have not fed parasitically. They've transformed directly from a larvae into an adult. And then the intermediate transformers, these are all Lampetra. This one you can just barely see as an eye spot developing. This is probably in like August. They start to get some of these features. At this stage, you can use the tail. This is classic Lampetra, where we've got really dark uniform in the center, and then these kind of clear opaque fins. And they'll start to transform in the fall. At this stage, it can be a little bit tricky to determine if it's going to be resident or if it's going to go to the ocean. So again, you've got tail characteristics. Sometimes they're not really quite ready to suction on because they haven't fully developed their oral disc. So you can use the tail for ID. But it's a little bit hard sometimes to determine the life stage. But once we get later in the season into winter and spring, you'll see really big differences. So the Lampetra that are going to stay are going to turn into that brown color. They're going to be basically these ones. And then the ones that are heading out to the ocean are going to get really silvery. So this is the Western River lamprey. This is the Western River lamprey. And they have a larger eye, kind of elongated head. They're just going to look like very different from the adult Western Brook lamprey. And that silver color is going to be really a defining characteristic. And then again, for ID, you can use the teeth to compare them to Pacific lamprey. So this is two Lampetra from the North Fork Nooksack River, and these were sampled in the exact same location. They are in the exact same life stage, so they both have eyes. They're in their kind of early-ish transformation from larvae into either adults or juveniles. We can confirm that they are both Lampetra. Looking at their teeth, they've got 3 rows of endolaterals. They've got their 2 defined upper cusps for their superorals. If you look at their tail, they also are Lampetra, but they are significantly different in size. So this one is about 180, didn't even fit in my fish viewer, and this one was about 120. And so they're in the same river, same location, same life stage, completely different sizes. So my theory is that this larger one is actually going to be their resident. It has gotten to a size that it will transform directly into an adult, because it can have enough eggs at that point. There's the trade-off of going to the ocean. It's hard, you have to make this big journey, but you're gonna get bigger, you're gonna have more offspring. But once those larvae kind of reach a certain size, we see that they just transform directly into an adult and spawn. They don't make that journey. So the guess is that this large one is gonna stay in the Nooksack. And then this smaller one, you can see they're quite different colors. This one has actually got this really cool green that I've honestly never seen anywhere. But this one might transform, it's a little early to say, into a juvenile river lamprey and head out to the ocean. Because it's just not as big, and it wants to go get feed and get a little bigger before it spawns. So pretty cool. You can see a lot of different sizes even within the same life stage. And then this is an example of 2 different transformers. Sometimes we call them transformers when they're in that intermediate stage, especially for Lampetra. So here's a Pacific lamprey juvenile, and then this intermediate transformer for Lampetra. If you look at the tails, you can see that Lampetra has this really dark uniform caudal ridge, and then the clear membranes for the fin. And then you can just see this tail poking out where it's much lighter at the tip. It's almost like translucent, and there's a little bit of pigment. It's kind of hard to see that one. But what we're really going to look at is the teeth. So we've got 4 rows of endolaterals on this one and 3 rows on this. So even though they kind of look like they're similar, they're actually 2 different species. And so we'll zoom in on the tail. Western river lamprey adults. We do not see these super regularly. I'd say they're like the most cryptic of all the cryptic lamprey. We have the least amount of data on these ones, but again, we're using the dentition to compare them and see if they are Western river versus a Pacific lamprey when they come back to spawn. So they can be overlapping in size. This is a great example of a Western river lamprey from Lake Washington that you would not necessarily know which species it is until you look at its dentition. And again, the juveniles are nice and silvery. They are looking like our smolts that they're going out to the ocean.
Knowledge check. Multiple choice. Select the best response to this situation. During a fish rescue, you have salvaged a lamprey. It is brown, 80 millimeters long, and has no eye or oral disc. 1. This individual is too small to identify with any confidence. 2. The lack of eye means the individual is a larvae. The color indicates it is a Lampetra species. 3. The lack of eye and oral disc indicates this is a larvae. Color is not a helpful feature for identification. This individual is large enough to identify. The important feature for ID will be the caudal fin. Or 4. The size indicates that the number of endolateral rows of teeth can be used for identification. One is incorrect because any individual larger than 65 millimeters is okay to identify. 2 is incorrect because color is not a useful identification characteristic. 4 is incorrect because this individual is a larvae and has no oral disc, including teeth. Oral discs are developed later on in the juvenile stage. The correct response is 3. True or false? This is a photo of a caudal fin and caudal ridge of a larval lamprey. You can tell by how the pigment along the caudal ridge transitions from dark anterior to light posterior at the tip that this is a Pacific lamprey. True.
So here's just some summary tables of characteristics to look for. And we also will have, we'll be sending out this, this PowerPoint, and then we also have a 2-page like field guide that will show characteristics for different life stages and different species.
Ready for questions?
Ready for
We
questions?
just have 2 so far. So is the microstomus the dwarf variant of the Pacific lamprey?
No. Yeah, that is still the same species. That is in BC, and it is considered a different species. So still very closely related to Entosphenus tridotatus, our Pacific lamprey, and likely, so, you know, I think we just want the things in boxes so much. And I think we've caught lamprey in certain areas kind of along that continuum of speciation. So that's like with our Western Brook and Western River lamprey, they might be on the way to being different species, but they're still genetically so related, that they are not considered different species. You know, we don't know how much they're, you know, spawning together and sharing those genes amongst those life history, but, you know, there's other examples from the Klamath Basin where we've got a ton of Entosphenus species there, but we haven't done a lot of research into like just how different they are. So they've got different life history strategies, but are they different species, or do we just catch them at this point where they're almost different species? Because we are the ones that are defining species, you know? And so I think that there's some cases where we've got like life history strategies, and then we've got different species, and in BC, we've got delineated different species. Yeah. So, yeah, it's still Entosphenus. So we're kind of lucky here in Washington to date. It's pretty easy because we've got one that's Entosphenus and one that's Blanchard, so we can tell them apart. But like, for example, in the Klamath, they're all Entosphenus and all the larvae look the same. Like, you just can't tell it. So, yeah.
Great. And the last question you touched on a little bit, it was about how difficult it is to look at their teeth unless you have a clear vessel.
Yes, a clear vessel is very helpful. So when they're just like, just not attached to anything, their mouth will be closed. It's kind of this funny little like flap thing. It's just like, they look really, really goofy when they're like that. But so it'd be really hard to see. But anything that is clear, they will attach to. Like I said, you know, sunglasses, glasses, they'll go right on it. Just push their
One right there, one right here.
Yeah. So yeah, but it is really helpful. If you have a fish viewer, oftentimes if you stick them in there, they will just suction on the side. For the mason jars, we'll also just kind of swirl them around a little bit, and then they'll suction on, so they stop swirling. It's usually they do it pretty readily. But it depends if they're in that early form of transformation, they don't quite have that suction capability, and so it can be hard, and that's when the tail can be a little bit more useful to ID the species, because they just don't quite have that suction instinct and capacity.